So, this is what we have seen till now, and this Q is such that its inverse would be its transpose. Now, next what we are going to do is we are going to move on to the concepts in mechanics. We have seen a bit of math till now, we want to apply this math to some physical concepts that we are going to use in mechanics. Okay. The first concept we are going to look at is the force, the concept of force. Okay. Basically, in the first lecture we saw that there are 4 concepts in mechanics, which is force, displacement, stress and strain, and we saw that in the first lecture in mechanics we saw that there are 4 concepts in mechanics, which are force, displacement, stress and strain. Okay. And then we saw that there are 4 relations connecting these concepts. Displacement and strain are connected through strain displacement relationship, stress and strain are related through the constitutive relation, the stress and force are related to the equilibrium equations, and then we know that the displacement and strain are related through the compatibility condition. The strain and displacement are related through the compatibility conditions. Okay. So, basically now we are going to start looking at what this quantity force is. From a first course in mechanics, you would have seen that what force is and what displacement is already. What is force then? Force is a mathematical construct that is used to explain the displacement. Okay. Force is a mathematical construct used to explain displacement of bodies. Okay. It is not an intuitive concept, you cannot measure force directly, you can measure only displacement that the force causes and infer what the force is. Okay. So, but we have been using this term force quite frequently in our day to day life, that we think it is a physical quantity which we understand, but if you think deep about it, it is not a physical quantity, it is a mathematical quantity which we use to describe displacement. Force is not the tiredness that we feel when we lift up a weight, force is not the muscle contraction is not the force, force is not something which you can quantify it physically. Okay. That is something you have to understand. In equipments like load cell, what you do which you use to measure the force is also you measure the displacement. There will be a diaphragm in the load cell which will displace, you measure the displacement of the diaphragm to infer what the load is. In a spring balance, for example, you place a mass, okay, or you calibrate the spring with respect to standard masses, the elongation that the spring undergoes under a standard mass, and you then decide on what is the calibration factor, and then you use that to measure infer the force. So, in all the circumstances force is not a physical quantity, but it is a mathematical quantity. Okay. Now, let us understand that what kind of a mathematical quantity is force. Is it a vector? Is force a vector? Scalar or some other thing? Okay. How do you know what it is? Can you demonstrate to experiments that it is a vector or is it a scalar? Force is a vector quantity. Okay. Force is a vector quantity, not because force is mass times acceleration and A is a vector, acceleration is a vector and hence force is a vector. But we know we can independently show that force is a vector quantity because it follows parallelogram law of addition, it does not follow scalar addition rules. What is the difference? If I write, if I have two forces F1 plus F2, okay, the magnitude of F1 is not magnitude of this is not equal to magnitude of F1 plus magnitude of F2. Okay. It depends upon the direction, in fact it will be lesser than or equal to F1 plus F2, unless F1 and F2 are orthogonal, this equality will won't hold true, it will won't be the sum of the magnitudes of F1 and F2. Okay. We can show this using a simple experiment. which you can do, 3 of you get together, put a ring in between, add 3 spring balances, okay, and 3 of you pull on 3 different directions. Say this one was F1, this is F2 and this is F3. Okay. The angle between them is not, this angle is not equal to 90, it is not equal to 90, it should be different from 90 degrees. Then what you will find is the spring balances, the resultant force that you have, say you took F1 and F2 and F3 as the basic forces, the resultant force F1 will be not sum of the readings of the spring balances here and here. At 2 and 3 spring balances we want to add up to give the value of the spring balance at 3. Okay. So, from this you can infer that force is a vector. From this experiment you infer that force is a vector quantity, okay, to see what a displacement is. Thank you.